Hello, my name is Joshua Mugabi. I welcome you to Biology King. And this session, we are going to talk about enzymes. Define the following terms. Enzyme. An enzyme is a globular protein that speeds up the rate of a chemical reaction by lowering the activation energy. That is a biological catalyst. Substrate. A substrate is a compound that binds to an enzyme's active site and is converted into a product. The substrate is complementary in shape and chemical properties to the active site. Outline the steps in enzymatic binding and catalytic activity with the aid of the following diagram. Enzymes and substrate collide in an appropriate orientation. Substrate binds to the enzyme's active site. Enzyme and substrate form a complex, leading to catalysis. Enzyme-substrate interaction shows specificity. Substrate is converted into a product. Enzymes may stress the bonds within the substrate to catalyze this process. Enzyme and product dissociate. Enzyme is not consumed by the reaction and may be reused. Identify factors that can affect enzymes' molecular motion and collision with a substrate. We should start with temperature. Temperature increases the kinetic energy of particles, leading to more frequent collisions. The second one is the substrate concentration. Substrate concentration increases frequency of collision with enzymes. The third one is enzyme concentration. The enzyme concentration increases the frequency of collision with substrate. Distinguish between the lock and key and the induced fit models of enzyme specificity. Lock and key. substrate and active sites are complementary in both shape and chemical properties, meaning that enzymes are specific for the reaction they catalyze. Induced fit. Active site is not a perfect fit, but undergoes a conformation change in shape to accommodate substrate. This stresses bonds in the substrate, promoting catalysis, and gives rise to broad specificity. Explain the effect of temperature on enzyme activity. We shall use the diagram. At low temperatures, there is insufficient activation energy for reactions to proceed. As temperatures increase, the rate of reaction also increases. That is, higher kinetic energy equals to more collisions. At a certain optimum temperature, the rate of reaction will plateau. That is peak efficiency. Above this temperature, the enzyme will begin to denature and rate of reaction will decrease. Explain the effect of pH on enzyme activity. We shall use the graph on the left. Enzymes have an optimum pH at which the rate of reaction is highest. At higher and lower pH levels, activity will decrease, leading to a bell-shaped curve. This is because pH affects the charge and solubility of the enzyme. The change in the enzyme's chemical properties causes it to denature. That is, loss of the tertiary structure. Explain the effect of substrate concentration on enzyme activity. Enzyme activity increases as the substrate concentration increases. This is because there are more substrate particles, leading to a higher rate of successful collisions. At a certain point, the rate of enzyme activity will plateau. This is because all enzyme active sites are occupied. The solution is saturated. Explain the benefits of immobilized enzymes in industry with examples. Immobilized enzymes have been fixed to a static surface in order to increase enzyme efficiency. Enzyme concentrations are conserved as the enzyme is not dissolved. Hence, it can be reused. Product is more easily separated from enzyme as the enzyme is fixed in position. Examples of immobilized enzymes in industry include in food production, medicine, and biofuel production. Outline the production of lactose-free milk. Lactase is fixed to agarose beads. Lactase purified from yeast or bacteria. Milk is passed over the immobilized enzyme, becoming lactose-free. Outline the advantages of lactose-free milk. This provides a source of milk and other dairy products for lactose intolerant individuals. It also increases sweetness in the absence of artificial sweeteners. It reduces the crystallization of ice creams because monosaccharides are more soluble and are less likely to crystallize. Suggest ways of measuring the conversion of hydrogen peroxide to oxygen gas by catalase enzyme. Measure time taken for an enzyme-soaked disk to rise in solution. Measure gas formation via pressure change with data logger or displacement of a syringe cap. Suggest ways of measuring the breakdown of starch into maltose by diastase enzyme. Measure the color change in a calorimeter. Starch is stained purple by iodine. Measure volume change via dialysis tubing. Starch is impermeable to tubing, but maltose is not. Suggest ways of measuring the digestion of pectin in cell walls by pectinase enzyme. You measure the volume of liquid produced as a consequence of the breakdown in cellulose. Measure the digestion of pectin via percentage weight change. Hello friends, thank you very much for participating in Biology King. I encourage you to subscribe.